Good morning, students. Today I'll start the fifth unit for final year drinking water supply and treatment, OEM 351. So water distribution and supply. So this is the syllabus, requirements of water distribution, components, selection of pipe material, service reservoir, function, network design, economics, computer application, appurtenances, leak detection, and the principles of design of water supply in buildings, house service connection, fixtures and fittings, system of plumbing and types of plumbing, etc. This is your syllabus. So one by one, I'll explain. So first, we'll see here water distribution system, and put that and share the PPT. What is mean by water distribution system? Water distribution system. Another PPT here. Distribution system. So what is meant by water distribution? After treatment, the water is conveyed to the consumers through the distribution network. So what are all the requirements of good distribution system? They should convey the treated water up to the consumer with the same degree of purity. The system should be economical and easy to maintain and operate. The diameter of the pipes should be designed to meet the fire demand. It should save against any future pollution as far as possible, should not be laid below the sea level. The water should be supplied without interruption, even when repairs are undertaken. The system should be so designed that the supply should meet the maximum hourly demand. So a peak hour 2.5 is recommended for the towns of population 0.5 to 2 lakhs. For larger population factor, 2 will be the adequate. Then, here you can see the layout of distribution system. So generally in practice, there are 4 different systems of distribution which are used. They are dead-end artery system, gridiron system, circular or ring system, then radius system. So we'll see one by one all the different types of. This system is suitable for irregularly developed towns or cities. In this system, water flows in one direction only into submain and branches. So the diameter of the pipe decreases at every 3 branch. So here you can see the main pipe. From the main, there is a submain. From the submain, there is a branch. Then there is a cut-off valves. The advantage of this dead-end system is discharge and pressure at any point in the distribution system is calculated easily. The valves required in this system of layout are comparatively less in number. The diameter of the pipe used are smaller and hence the system and hence walls required in the system of a comparatively less number. The diameter of the pipe used are smaller, hence the system is cheap and economical. The laying of water pipe is used are very simple here. So only one main, and from the main there is a sub-main, and sub-main to branch, and cut-off walls are less number. The laying of water is very simple. The disadvantage is there is a stagnance of water at dead ends of pipes causing contamination. During repairs of pipes or valves at any point, the entire downstream end are deprived of supply. So the water available for firefighting will be limited in quantity. And the next is gridiron system. So it is in the grid form. The main water enters the branches at all junctions in either direction into submains of equal diameter. All the pipes are at equal diameter. At any point in the line, the pressure is balanced from two directions because of interconnected network of pipes. So here you can see there is a main pipe and there is a submain. From the submain, the branch is connected to all directions. And all the branch, there is a, you can see submain, each submain to branch, there is a three cut-off valves. So in case of any repair, here the advantage is very small portion of distributor will be affected. Every point receives supply from two direction and with the higher pressure. Additional water from the other branches are available for firefighting. There is a free circulation of water, hence it is not liable for pollution due to stagnation. More length of pipes and number of valves are needed, hence there is increased cost of construction. Calculation of sizes of pipes and working out pressure at various points in the distribution system is laborious, complicated, and difficult. So here more number of valves. So the disadvantages, pipe size calculation and the system of distribution is tedious. Circular or ring system. Supply of the inner pipe is from the main around the boundary. It has the same advantage as the gridiron system. Smaller diameter are needed. The advantage and disadvantage is same as the gridiron system. Here you can see the ring system. Here the outer peripheral, there is the main, then the inner to inner submains are there, and the cut-off valves in both the direction. The next is radial system. This is zoned system. Water is pumped to the distribution reservoir and from the reservoirs. The water is pumped to the distribution reservoir and from the reservoirs. It flows by gravity to the tree system of pipes. The pressure calculation are easy in this system. Layout of roads need to be radial to eliminate the loss of heating winds. So this is most common, most economical system. Also, it combined pumping and gravity service. The radial system. So, what are the method of supplying water? So, there are three methods: continuous system, intermittent system. Two methods. This is system of supply. Continuous means all the 24 hours water is supplied to the community. Then intermittent supply means the system is suitable when plenty of water is not available. Supply is divided in zones and only at fixed hours in a day they will supply that to limited duration, 3 hours or 4 hours like that. I will show this method of supply. Here you can see methods of water distribution. There are three methods. One is gravity system, pumping system, combined gravity and pumping system. So what is meant by gravity? This system is suitable when source of supply is at sufficient height. Most reliable and economical distribution system. The water head available at the consumer is just minimum required. The remaining head is consumed in the frictional and other losses. The gravity system. So the reservoir is height and the consumer is in the lower level. So there are no need of pumping. Through the gravitational force, the water is supplied to the top. pumping system, treated water is directly pumped to the distribution main without storing. So also called pumping without storage system. This directly it will supply. High lift pumps are required. If power supply fails means there is a complete stoppage of water. So this method is not generally used. Pumping system is not generally in combined gravity and pumping system. Most common system, treated water is pumped and stored in an elevated distribution reservoir. Then supplies to the consumer by action of gravity. The excess water during low demand periods gets stored in reservoir and gets supplied during high demand period. So it is economical, efficient, and reliable system. So this is the combined gravity system. So with this, I'll stop. So today we are seeing what are all the requirements for good distribution system. What is meant by distribution system? Requirements. Then layouts of distribution system. There are four methods. Then supply of distribution, continuous and intermittent, and methods of water distribution. Three methods. What we have seen all this. In the next class, I will start with the reservoir. What are the reservoir? Pipe appurtenances, pumps, etc. We will see in the next class. Okay, thank you for your patient listening.